Hello, fellow mathematicians. This is Ms. Ledbetter. Welcome to the very first video for the 2015-2016 school year. I am so glad you're here and along for the journey. Let's get this show on the road. Today we're going to be talking about function operations. So we've talked about functions in class, how to name them, how to use them, and now we're actually going to be doing some calculations, some computations with those functions. So you should be recording this in your interactive notebook on page 5. Make sure that you are taking diligent notes because you will have a quiz tomorrow in class and you will be able to use your notes. So your notes are going to be very important for you. Okay, so before we actually do any of the work, let's go back and review function notation. So remember that when you see an f parentheses x, or it could be g of x or h of x or whatever, the f doesn't matter, but the parentheses x, anytime you see that, that is function notation. And so whatever value you see inside the parentheses in place of x, that would be your input value. So like if they give you f of -3, then you would plug in a -3 everywhere you see an x in that equation. And then the answer that you get back out, which is known as your y, that would be your output, or the answer that you get after you plug in that value that they gave you for the x. So input versus output, you can also substitute these words to be the domain and the range. So the domain is what goes in the function, range is what do you get when you get out the answer or your output. So really there's 4 operations we're going to be using with our functions because there are 4 operations in math in general. So we're going to add, subtract, multiply, and divide. So if you happen to see an parentheses f plus g and then the parentheses x, what that really means is that you're going to take the f of x function plus the g of x function. So we've got 2 different equations, 2 different function rules that are going on, and if you see f plus g, that just means add the 2 equations together and combine like terms. Same thing for subtraction. F minus g means I'm going to take the f of x function minus the g of x function, multiplying f times g, or dividing f divided by g. Now, the important thing to note here is that the order is important. Whatever letter comes first, then that has to be the first function you're going to use in your function operations. So f plus g means I'm going to add the f function plus then the g function. Now, it's not so much a big deal with the adding and multiplying because order doesn't really matter when you add or multiply. However, subtracting and dividing, order is very important, so pay attention to that. Okay, so let's start with 2 functions. We have f of x equals 4x plus 7 and a g of x function that is 12x or 12 plus x. So let's say that the first question or our first operation is we wanted to add these 2 together. So really what that means is that I'm just going to take the f of x function and plug that and plus add the g of x function. Or, in other words, I'm going to take 4x plus 7 plus 12 plus x. So then really all I have to do is just simply combine like terms. So if I have 4x plus x gives me 5x, and then 7 plus 12 gives me a total of 19. So final answer for the f plus g of x function rule is f 5x plus 19. Okay? So then now, what if we wanted to subtract rather than adding? Same thing, I'm going to take f of x and subtract the g of x function, or in other words, 4x plus 7 minus the 12 plus x rule. So then, notice how I have parentheses here, whereas I didn't do the parentheses before with when we were adding, because when you're adding, the order isn't really that big of a deal, so I really don't need the parentheses because I'm just going to end up combining like terms. However, when I'm subtracting, order is important because I'm actually going to be subtracting all of the 12 plus x function. I'm not just subtracting 12, but I'm subtracting all of 12 plus x. So really, it's like I'm going to be distributing that minus to both the 12 as well as the x. Here's the catch where a lot of people go wrong whenever you see something like this. They think just subtract 12 and then leave the plus x. No, that doesn't work, because you actually have to end up distributing that minus sign. So really what that looks like is 4x plus 7 minus 12 minus x. Then we can combine the like terms, so 4x minus x gives me 3x, and then 7 minus 12 is now minus 5. So final answer for f minus g of x is 3x minus 5. Okay? So that's adding and subtracting. Not that big a deal. Now let's look at multiplying, dividing. H of x and k of x, so two different functions. So let's look first at multiplying. Okay, so same thing. When you see h dot g, remember that the dot, now that we're a little bit older in high school, we don't have to use the x when we mean multiply. We use the little dot symbol because the x, if I use x, then that's going to be confusing with my x variable. So I don't want to use x in too many places to represent too many different things. It's just confusing and I just don't want to go there. So we use the little dot to represent that we're multiplying. So this means that I'm going to take the h of x function and multiply that with the k of x function. Again, notice that I'm using parentheses here because yes, parentheses will be a big deal when I am multiplying, because ultimately if I am multiplying something like this where h of x actually has 3 different terms and I'm multiplying by the k of x, which actually has 2 different terms, I really ultimately need to be multiplying every single term with every single term from the other. Or you might know this more formally as FOIL, or maybe that's informally, I don't know, whatever that would be. But anyway, FOIL. So if you don't remember FOIL, we'll talk about it, it's a thing. FOIL is F is for the first, so I'm going to multiply 3x squared times 3x, and then O is for the outsides, 3x squared times the 1, I is the inside, L is the last. Now, FOIL really only works if you have 2 terms times 2 terms, known as binomials. So if I'm multiplying a binomial times a binomial, like the 3x plus 1, unfortunately, h of x has 3 different terms, so that's called a trinomial. So FOIL doesn't really work. But ultimately, what I'm trying to do is take every term from the h of x function and multiply that by all of the k of x, which is the 3x plus 1. So I'm going to take 3x squared times 3x plus 1 minus 11x times 3x plus 1 and minus 4 times 3x plus 1. So really what this comes down to is just a really big distributive problem. So I'm going to distribute 3x squared with the 3x plus 1, get 9x cubed plus 3x squared, a negative 11x. Don't forget to take the negative with that. The minus sign always follows the number that's right behind it. So I'm going to multiply negative 11x times 3x, which is negative 33x squared. Negative 11x times 1 is negative 11x. Duh. And then same thing for the negative 4. Don't forget to take the negative. Negative 4 times 3 is negative 12x. Negative 4 times 1 is minus 4. Okay? So really, ultimately, when you multiply multiple functions, you have to make sure that you multiply every term from one equation with every term of the other equation. So yeah, they can get pretty big. There's several different answers there. But now we can combine our like terms. So if I'm considering like terms, look at 9x cubed. Unfortunately, there are not any other x cubes, so he doesn't have any friends to play with. He's going to stay by himself as just 9x cubed. Then 3x squared and a negative 33x squared gives me negative 30x, negative 11x, negative 12x, negative 23x, negative 4. Unfortunately, also, negative 4 doesn't have any friends to play with. There aren't any other just numbers by itself. So negative 4 is just negative 4. And so that is your final answer when we are multiplying the h of x times the k of x. So final answer would be 9x cubed minus 30x squared minus 23x minus 4. And that's as simple as it gets. I can't combine anything else. So now let's look at dividing. Okay, same 2 functions, h of x and k of x, but now let's actually divide them. Okay, so really what that means is that I'm going to take my h of x function rule divided by the k of x function rule, or in other words, 3x squared minus 11x minus 4 divided by 3x plus 1. Now, because we are doing this so early on in the year, if you don't remember how to factor, I'm not going to hold your feet to the fire. It's not going to be that big a deal. We will get to it. You will know how to do it. But ultimately, right now we have enough on our plate just doing all these different operations. So this would actually be the final answer that I'm looking for. So as long as you can show me that I'm taking the h function in the numerator and the k function in the denominator, I'm happy, as long as you can get there. Now, if you do remember how to factor, the h of x function can be factored. 3x squared minus 11x minus 4 can actually be factored into 2 different terms, or binomials, 3x plus 1 times the quantity of x minus 4. Now notice if I do factor that, then I have a factor of 3x plus 1 in the numerator and 3x plus 1 also in the denominator. Then if I cancel those two, because 1 on top divided by the same thing on the bottom, they just go away, they cancel each other, it becomes 1, then all I have left is just that x minus 4 factor. So ultimately my simplest answer should be x minus 4. But again, like I said, it's early in the year. I know you've at least slept a little bit, I hope, since you were in Algebra 1 class, so you probably don't remember how to factor, but it's okay, we'll get there. I'm not worried about it. So, now it's your turn. So here are 4 different function rules, and with 4 different function rules, there are 4 different practice problems. So at this point in the video, I need you to pause and do your own calculations to see if you can figure out each of these function rules on your own. And when you come back after having worked all of these problems, then you can continue the video and you can check your answers to make sure that you are actually doing this right. And don't forget that you will have a quiz tomorrow in class, so you might actually see these questions again. Hint, hint, wink, wink. So at this time, pause the video, do some math, and then when you're ready, click it back on and check your answers. Okay, so now it's time to check. Hopefully, you've worked all of these on your own. So therefore, here are all of your answers, and you can check to see if you got the same thing that I did. If not, look back over it, see if you can figure out why you missed what you missed, kind of a thing. Be careful when you're combining like terms. Special note for the division problem, h of x divided by k of x. If you know how to factor, that x squared minus 9 can be factored. That's actually a perfect square. That can be factored with x plus 3 and an x minus 3, so then you have the x plus 3, same factor on both the numerator and the denominator. That would cancel. If you didn't, that's totally fine. This would be your final answer. Or if you did factor it out and you canceled out the common factors, then your final answer in its simplest form should be x minus 3. But I'm not going to hold you to it as long as you can show me that I'm taking x squared minus 9 divided by x plus 3. I'm happy, no points lost. So that is it. You've just successfully completed the first video for the 2015-2016 school year. Hopefully you understood everything. If not, hey, it's a video. It's on YouTube. Go back and replay it. Try it one more time. If not, see if you can find some other videos. It's all up to you. But keep in mind, you will have a quiz tomorrow in class, so you need to make sure you know how to do it. Okay? Hope to see you next time.